Hello, my name is Mr. Wyrick, and I'm here today to talk to you about Lesson 9.4, the fourth lesson from Chapter 9, and this one's about composition of translations. Now, we've been doing translations up to this point. We've translated, we've rotated, and we have reflected, and that's kind of a review of some stuff that we have done. So now we're getting into the real meat, the complicated stuff from this chapter. So let's take a look down here on what I have written. First off, you need to make sure you add composition of transformations to your notes. It means we are making more than one transformation. So we're making a translation or a slide and then a reflection, or we're making two reflections and it's in a sequence. So if we reflect it first and then move it, it's not a movement to the original. It's the movement to the reflection. So you have to remember that it's in a sequence. A glide is one of the examples that they give you first to put down in your notes. It's a definition. A glide reflection is reflection and translation along a vector. And their example is really good. It's like a little footprint here, okay? And I'm going to do it with a dog footprint. But we've got a vector here. So this footprint is on this side. We have reflected it to go from a right foot to a left foot, and we have translated it along. So now it looks somewhat like that. Okay, so we have reflected it across the line to like this ghost image that would be here, and then translated it up to this point. There's going to be a couple of glide reflections that you'll have to do here. When we're talking about we're combining two of them, it's isometry. And really, this is just a vocabulary word. You need to make sure you take this down. You can take a look at it. It should be on page 654. But if you're in Miss Payne's class, if you're in Miss Kiefer's class, you're doing the definitions. You know, ISO means same, and met means measure. So we make these reflections, we make these translations and all this stuff, and it ends up being exactly the same size. Now, 9.2, Theorem 9.2 is talking about reflections in parallel lines. So if we have a set of parallel lines, which I've got these two right here. So what they're talking about is if I have a shape out here like this triangle, and I reflect it first across this parallel line and then across the other parallel line. So I've got this reflection first, or something approximated to that one, and then I've got another reflection over here. Notice my distance from this one is further because it was closer to this line. So I'm going to go that same distance here, and I'm going to end up with something that's approximate, well, not approximate. It should be congruent to my original shape. And it is, if we take the distance from this parallel line to this line, the whole thing, if we call this x, this whole movement is 2x. So if I know the distance between the parallel lines, I can find the distance across the two reflections if I'm to make a reflection across the parallel lines. They say that this right here, this 2x, they call that their translation vector. So make sure you get that down in your notes as well, your translation vector, and it's perpendicular to that translation vector, double the distance of those parallel lines. Now the last thing, well, not the last thing, the next last thing I'll talk about is Theorem 9.3, which is reflections of intersecting lines, and it's a rotation around the intersection point. So if I have this line and this line here, where they intersect, and for making it easy for me, I'm going to make it a circle, because circles, no matter how you reflect them, it's always going to be the same thing. So if I were to measure my points out and reflect it across this line and then reflect it across the other line, what's going to happen is I am going to rotate around this point. We'll call it point A. And the rotation around this point is actually going to be, again, if this angle here is x, my rotation angle, the whole thing, is going to be 2x. So again, yeah, I'm going to make this one a lot smaller. If I have a triangle right here, what's going to happen is I'm going to find this angle and I'm going to double it, and then I'm going to make this into a rotation around that line that would cover both of my reflections. So if this is a 35-degree angle, I'm going to rotate the whole thing 70 degrees. So you can refer back to the lesson on rotations if you need to refer back on how to get that one done. So if there are any questions about this stuff, if you need to go over it, make sure to come up to me in class. The last thing that they talk about is patterns and being able to apply one of these things to patterns. Like you see a pattern in the carpet, you see a pattern in the tiles in the hallway, then what is going on with it? It's some kind of composition of transformations. So is it a glide? Is it reflections on intersecting lines? Is it just a rotation? Whatever it is, be able to identify that. Make sure you take a look at that. That's going to be on page 655. And other than that, we will see you in class.